In the 1950s, movie theaters were panicking. Families were staying home to watch television, so Hollywood scrambled to get people a reason to leave their living rooms. They tried everything from widescreen formats to synchronized 3D glasses to pull audiences back in. But one group of producers decided to go further than optical illusions. They wanted to physically alter the air inside the auditorium, pumping artificial odors directly into the audience's faces to trigger their sense of smell. The project required an industrial-scale engineering effort. At a theater in Chicago, crews installed over a mile of plastic tubing, threading it underneath individual seats to deliver highly specific scents directly to the audience. It cost a fortune, and audiences hated it. Critics mocked it so relentlessly that the entire concept of scented cinema was buried and ignored for the next 60 years. But looking back at the science behind this disaster reveals something surprising. The engineers weren't wrong. They were actually trying to execute a highly effective neurological hack. They just built it half a century too early. To understand why filmmakers wanted to pump odors into a crowded room, you have to look at how human anatomy processes sensory information. This diagram illustrates the pathways of our senses. Every time you see or hear something on screen, those signals hit a relay station in your brain called the thalamus before you consciously process them. But smell works differently. Through a pathway called the olfactory bypass, scent information travels directly to the amygdala, the region of the brain that handles instant emotional reactions and memory formation. A Swiss scientist named Hans Laub understood this biological loophole perfectly. He spent 2 decades trying to build a machine that could exploit it, eventually demonstrating an early prototype to crowds at the 1939 New York World's Fair. This diagram shows the core mechanics of Laub's finalized invention, which he called the smell brain. A secondary audio track on the film reel acted as a synchronized trigger. When a specific cue played, it sent an electronic signal to a mechanical valve, which then pushed compressed air through a vial of concentrated liquid scent. Installing this system cost about $30,000 per theater in 1960. It required a centralized machine to precisely route 30 different aromas through a massive labyrinth of pipes, ensuring targeted delivery to each individual viewer. Hollywood royalty threw their money behind the invention, leading to the 1960 premiere of Scent of Mystery, starring Elizabeth Taylor. The film was entirely structured around 30 distinct smells, like pipe smoke and garlic. These were injected into the theater, so the audience could track specific characters or identify the mystery woman by her perfume. Hans Laub successfully engineered a machine that connected a strip of celluloid film directly to the human nervous system. What he failed to account for was the unpredictable physics of moving air through a shared public space. Before Laub's system even had a chance to premiere, a public relations executive rushed a cheaper, competing technology to market. He called it Aromarama, and it triggered a vicious corporate rivalry that the press dubbed the Battle of the Smellies. Here, we can see exactly how the two competing systems approached the engineering problem. Aromarama relied on brute force, dumping aerosol canisters directly into the theater's existing air conditioning vents. Smell-O-Vision used Laub's highly precise individual puffs of air emerging from beneath specific seats. Aromarama's top-down method failed immediately. The injected fragrances mixed with the theater's standard deodorizing chemicals, resulting in almost every environmental effect smelling strangely like celery. Smell-O-Vision had its own fatal flaw. Because compressed air takes time to travel through a mile of physical tubing, people sitting in the balcony received the corresponding aroma seconds after the visual had already passed, completely destroying the film's synchronization. Furthermore, pushing compressed air through hundreds of plastic valves is inherently noisy. Every time a quiet, dramatic scene played on screen, it was accompanied by a loud, highly distracting mechanical hiss. Between the delayed smells, the hissing pipes, and the nauseating celery odors from the rival system, audiences were exhausted. Critics slaughtered both formats in the press, training the public and the film industry to permanently reject scented cinema. The machines from 1960 were scrapped, but the underlying commercial desire to physically immerse an audience in a story never actually went away. Today, the modern successor to those early experiments is the 4DX theater format. It successfully integrates physical environmental effects, including synchronized scents, directly into global blockbuster screenings. Operating in over 780 theaters worldwide and generating massive box office returns, 4DX proves that Hans Laub's core concept is highly viable when the delivery actually works. But the ultimate evolution of Laub's blueprint belongs to a company called OVR Technology. They managed to condense an entire mile of 1960s plastic tubing down into a single cartridge that snaps onto a virtual reality headset. By placing the scent delivery system directly over the user's nose, rather than routing it across a crowded room, this VR architecture completely eliminates the diffusion lag that ruined the balcony experience at the Chicago theater. This chart compares delivery times. instead of noisy compressed air valves. The VR system uses piezoelectric vibrations to instantly atomize liquid scents. This allows the cartridge to switch between 250 smells in a tenth of a millisecond in total silence. Hans Laub's effort to synchronize film with the emotional centers of the brain turned out to be technically viable. His original blueprint for a direct neural shortcut simply had to wait 65 years for engineering to catch up to anatomy.